So today here we are going to have what is increasing and decreasing functions. So let me define here. So we say here, I'm just write the definition. We say that f here, f is decreasing, sorry, f is increasing, f is increasing. So our f here is increasing functions, increasing function. I write short in function in short on the interval, so you have specific interval, and on the interval, just write on the interval for any, if you have f of x1 less than f of x2 less than for any bear, I'm just writing the definition here, for any bear x1 less than x2 less than x1 less than x2. So as you can see, when x1 less than x2, then your f, the value f at x1 less than the value f at x2. For example, here, if I have a function like this, that is your x here, right? And that is my y or f of x, right? So if I take here x1 here, and here, that is your x2 here, it's very clear on the graph here, x1 less than x2. x1 less than x2. So now if I look to the value f at x1 here, that is the value f at x1, and here that is your f at x2. So it's very clear f of x1, still the value f at x1 here, that is the one here, less than the value f of x2 here, right? Less than f of x2. So this function, we call it increasing. The function here is increasing. If you have, when you have x1 less than x2, take any two number on the graph, x1 less than x2, then the value of f at x1 should be less than the value of f at x2. If you have that, then the function here is increasing. So here is increasing here from the graph, but usually the function, if it's very complex or very complicated, then it's not easy to sketch the graph. So you need kind of algebraic way or another way to figure out where is f is increasing, where is f is decreasing, as I'm going to show you now. So that is this way here, we call it algebraic way, because I took two pair, x1 less than x2, then the value f at x1 less than the value f at x2. So for example here, if you have f of x here, f of x equal x squared, and then I give you the domain here, x between 0 and 0 to infinity, right? So here, what is the graph of f of x equal x squared? The graph here, it's a parabola, but here they tell you from 0 to x squared. So here, so that is your f of x here, and that is my x. So that is parabola here, x is, but here the domain starts from 0 to plus infinity. So that is the graph of your f of x here equal x squared. It's a half this one. This one is increasing, yes. That is from the graph. Assume here the graph is not easy to figure out. Here is your domain, x greater than or equal 0, and also positive. So what do you have? If I take any two number you wish, like for example 1 less than 2, is 1 less than 2? Yes. So now I need to get the value of f of 1, and here what is the value of f of 1? Here is your f of x. Go ahead and replace x by 1. So if I replace x by 1, you get 1 squared, which is 1. What is f of 2? F of 2, here you have 2 squared, which is 4. So now f of 1 less than or equal f of 4. So as you can see, your 1 less than 2, but the value f at 1 is still less than the value f at 4, at 2, then which means what? Which means this function here is increasing. This function here is increasing. Okay? All right. So now I have to define here when f is decreasing. F is decreasing here. So f is decreasing. So here I'm just, that's another definition here, f is decreasing. If you have x1 decreasing, all right, so just let me write it here, decreasing. If you have x1 less than x2, if you take any two pair, x1 less x2, then you are going to get f of x1 greater than f of x2. You see this inequality here, less than, then what happened here, your f of x1 is going to be, your inequality is going to be switched from less than here less than, to greater than. less than to greater than. If you have that, then the function here, it will call it decreasing. For example here, if you take a function like this, coming down like this, okay, so that is your f of x here, that is your y-axis, right, and that is your x. What happens if I take here, that is your x1 here, that is your x1, then I take x2 here, right, x2. What happened here in the graph, x1 less than x2? This graph is very clear, is what is decreasing, right, is going down, decreasing, right? So x1 less than x2. Then what do you have here? It turns out, what is the value of, that is your f of x here. So what is the value here? What this one here? That it will be f of x1. What is the value here? It will be f of x2. That is when x2. So it's very clear on the graph, f of x1 greater than f of x2. So f of x1 greater than f of x2. As you can see, when the inequality switch like this, from less than to greater than, become decreasing. Here, when you have the increasing, your inequality is still the same, less than, and here less than. Your inequality does not change, but here for decreasing function, the inequality is going to change. x1 less than x2, then f of x1 greater than f of x2, then the function here we call it decreasing. The function here is calling decreasing. That's one way. Another way, I'm going to explain many ways here about increasing and decreasing. About slope. Remember when I gave you in the class, what is the slope? The slope here for nonlinear function is nothing but your derivative at a. Your derivative at a. Here, when I have a linear function y equal mx plus b, or say, for example, 2x plus 1. If you have 2x plus 1, what is your slope here? Your slope here is 2. So here your y is going to increase by 2. Y increase by 2 unit. Your y increase by 2, right? By 2. When x increase by how many unit? When x increase by 1 unit. When x increase by 1 unit, right? Just let me write by 1 unit, right? So that is your slope. So what happens if your slope equal negative 2x plus 1? Negative 2, the slope is negative. Then your y here is going to decrease by 2 unit, because it's a negative 2 unit. 2 unit when x increase, again when x increase by 1 unit, when x increase by 1 unit, right? When x increase by 1 unit. Okay guys, so here as soon as I look to the slope here for linear case, if it's a positive, then I can figure out y increase by 2. If it's a negative, then y increase by negative 2 here, by 2, decrease by 2 because it's a negative, right? So now that is for linear functions. So now if I go for nonlinear, then I have to take the derivative. So here, if you look to the increasing function here, look what you have, your slope here. If I take slope, how to get the slope of this function? The slope is nothing but it's a tangent line. There's a slope. If you have a tangent line for this, it's very clear this slope is what? Is going up, increasing. Is going up, increasing. So here, if you take a slope here, it will be kind of increasing, right? But when you have the function decreasing, maybe I change the color to see the difference. So here, if here, what is your slope here? Your slope here is like tangent line here. As you can see, it's decreasing. Your slope here is negative, decreasing. And here, if you take tangent line here, also decreasing. Because that is a nonlinear function. And the slope of nonlinear function is nothing but your derivative at specific number. At a, it could be here x2, it could be x1. But if I take tangent line, the slope of the tangent line, or the slope of your f, which is decreasing nonlinear functions, should be the slope. And here the slope is going what? Is decreasing. And the slope here for increasing function, look what you have. The slope here is what? If I take tangent line, is going up. If I take tangent line here, is going up. So here the slope is increasing, which means the slope is positive. And there the slope is decreasing, which means the slope is negative, right? So now, in order to I need to show you something. You know, what is the definition of the derivative? F prime of a, the definition of the derivative, limit, right? H close to 0, f of a plus h minus f of a over h, right? That is the definition of my derivative. So now, what happened if I take h close to 0 from the right? H close to 0 from the right. H close to 0 from the right, like h positive number, so 0.0001. So now, what is which one is bigger? A plus H bigger than A, which one is bigger? Or A plus H is bigger than A, right? Because your H here is what? Positive number, close to H from the right. So now, if I tell you F is increasing, then what do you have? F is increasing means your F of A should be less than your F at A plus H. So that is your X1, that is your X2, X1, and that is your X2. So what do you have? F of A less than F of A plus H. Then what do you have here, guys? So if I take this term to the other side, then you have 0 here, and it will be F of A plus H minus F of A, right? So F of A plus H. If I take the other side, it will be minus F of A. So now if I look to my derivative here, what do you have in this fraction? F of A plus H minus F of A, which is what? Is positive. What do you know about H? H also is positive. So here, F of A plus H minus F of A, look what you have. This one, it's positive. F of A plus H minus F over H. And also H here is positive because, why? Because it's 0.001, close to 0 from the right. Then what do you have? What I have here is, H close to 0 from the right. So your derivative here, F prime of A equal limit H close to 0, F of A plus H minus F of A over H. I know H positive. I know this term also positive. That's a positive. And this one here positive. So positive over positive give you your derivative is what? Your slope. That is your derivative or slope is positive. F of A prime of A here is positive, right? Positive. So which means I start when F is increasing, I end up here is F is what? Is positive. F here is positive here. So I'm just explaining that. So what is the conclusion here, guys? The conclusion here, that is one of the theorem in mathematics. Here we are going to use it. If you have F here is increasing, right? My handwriting, because the tablet here, F is increasing, right? Then if and only if your derivative greater than or equal 0. So sometimes we will say greater than 0. We call it that's kind of strictly positive, right? Or sometimes it write greater than or equal 0. So here let us write it here greater than 0. But you could have greater than or equal 0 as I mentioned in the class here. So either greater than 0 or so that is kind of, we call it increasing, but you could have strictly increasing when you have greater than 0. So if you have greater than or equal 0 is acceptable because it's increasing. If you would like to call it strictly increasing, then you have to take this one here, just strictly positive, but greater than or equal 0, just say it's simply increasing. But it's okay if you say increasing greater than or equal 0 here. It's okay if you say greater than 0. I'm not going to make fuss. So if it's increasing, if your derivative greater than 0, so here I could take the derivative and then I figure out the derivative greater than 0, then I know F is increasing. So that is if and only if. Also F is decreasing. So your F is decreasing, right? If is decreasing, if and only if, that is two direction. If and only if your derivative is negative, less than 0. Your derivative less than 0, less than or equal 0 is okay. So F is decreasing if your derivative less than or equal 0. So that's from the graph you could figure out here. Look what you have. The slope here is steep. The slope here, the derivative, the slope is steep, and that is negative, right? Or you can use this definition here, but you take H close to 0 from the left. H close to 0 from the left. Or let me show you here. If you have A and A plus H, if H here close to 0 from, if you know F is decreasing, then what do you have? If you have A less than A plus H, I show you here. So, but that is the one I really care. I'm going to use. If I know F is decreasing, guys, F is decreasing, in the same example that I gave to you, then if you know A less than A plus H, right? Again, here H is what? Positive. Take H close to 0 from the right. Then if I know F is decreasing, then the value F at A should be, your inequality should be switched to from less than to greater than. from less than to greater than f of a plus h, right? So that is, the function here is decreasing, right? So now, if you look to this, what I have here, if I take f of a to the other side, then what do you have? F of a plus h minus f of a. So the difference here is what? Less than 0 means it's negative. Less than 0, it's negative. So what is my definition here? The derivative at a, the slope, that is your slope, or your derivative at a, it will be limit h close to 0, f a plus h minus f of a over h. Right? What do you know about h? H is what? Positive. You know h is positive. And what is the difference between f a plus h minus f of a in this case? Because f is decreasing. The difference here, as I mentioned, is negative, less than 0. So here, this one here, it's less than 0, but this one here is greater than 0. So what do you have? You have negative over positive. Negative over positive. If you have negative over positive, means your derivative is what? Is negative. Your derivative is negative, right? F prime of a negative. All right, so what is the conclusion? The conclusion, f is decreasing if your derivative is less than or equal 0, is negative, right? So let me give you why is important all of this. Because I have to find the interval. Here, guys, when I, before I give you example here, why is important, or how I'm going to use this? Because here, if I tell you, can you solve x plus 1 greater? So if you have inequality greater than 0, that's called the inequality, or less than, or greater than or equal, or sometimes less than or equal. If you have one of these, we call it inequality. So if I ask you to solve this one, here, for example, here, x plus 1 greater than 0, that is not equation, that's called inequality. How to solve this? X plus 1 greater than or greater than 0 means your x greater than negative 1. X greater, take 1 to the other side, become negative 1. How to graph this one? Here is your negative 1. Negative 1 here, it's open, negative 1. Because you don't have equal. You don't have equal, so you have negative 1, and you keep continue greater than in this direction. So so negative 1, it's open from negative 1 to plus infinity. Negative 1 to plus infinity, because anything greater than negative 1, it will be in this interval. So because that is inequality, then the solution of this inequality, what do you mean solution here? Solution of this inequality is interval. So if you have one of these called inequality here, if you have any inequality, the solution of any inequality, it could be interval, it could be more than one interval here, but we, for simplicity, we say interval. So now, why is it important here? The solution of any inequality is interval, because our statement here, when I told you f is increasing, then your derivative greater than or equal 0, that is inequality. Greater than or equal 0, that is inequality. And that is also like interval. So here, I try to figure out the interval where f is increasing and the interval where f is decreasing. So if I tell you what is the interval f is increasing and where is f is decreasing, then you have to take the derivative greater than or equal 0, and that is give you interval. So let me show you by example here, instead of talking. So one example here, I give you, so example number 1, here I need to find the interval, find the interval where f is increasing and decreasing, where f is increasing and decreasing, right? So I need to get the interval. Where is the interval where f is increasing and decreasing? So let me give you f of x here, one of the example here. F of x equal here, it will be x to the power 4 minus 2x cubed. X to the power 4 minus 2x cubed. I need to figure out where f is increasing and where is f here is decreasing. Okay, guys? So here f is increasing, decreasing. So I'm going to assume f. First, let us assume your f is increasing. Your f is increasing, right? So let us assume f is increasing. So now, f is increasing if and only if your derivative greater than or equal 0, right? So here is, I have to get the derivative of this one. So what is the derivative? 4x cubed minus 6x squared. Right? Minus 6x squared. So I need to solve this inequality here. So that is your derivative greater than or equal 0. That is inequality. Yes, it's inequality because you have greater than or equal 0. So now let me call this one star. That is inequality. How to solve any inequality? usually is two-step. What is step number one? To solve any inequality, you make it equal to 0. Make it equal to 0. So you have 4x cubed minus 6x squared. Equate that to 0. Now go ahead and solve this for x. How to solve this one for x? You have x squared, you have x cubed, so I can factor x squared. Right? So if I factor out x squared, then what you have 4x minus 6. That is close equal 0. I factor out x squared, so you have 4x, and here from here you have negative 6, and then I have to go ahead and solve this. So now you have so-called zero product. What is zero product? A multiplied by B equals 0, right? So A, it could be A 0, or it could be B 0, or it could be both of them are 0. Both of them are 0, right? Both of them are 0. So A multiplied by B equals 0. Then A could be 0, or B could be 0, or both of them 0. Because 0 multiplied by anything, you get 0. So at least one of them must be 0, right? So here you have a product, that is your A. So your x could be x squared equals 0, or 4x minus 6 equals 0. So what is x squared equals 0? That is x multiplied by itself how many times? 2 times x multiplied by x. So again, x multiplied by x equals 0, then your x equals 0. Right? Because here is the rule. If you have x multiplied by x, so A could be 0 or B equals 0. So here x repeated twice, x multiplied by x, which is x give you x equals 0. So now here I need to solve this one here. So 4x equals 6. Take negative 6 to the other side, and then solve that for x. Divide by 4. So what did you get? You get 6 over 4. So you get 1.5. Right? 1.5. Right? So 1.5. So that is step number one. I make the inequality, make it equal to 0, and go ahead and solve that for x. And then step number two, I should, here is your entire real line, the whole real line here. And then I put you have 0. Where is 0? It's here, 0 here, and you have 1.5. It's here, right? So I put the two line on the two number on the real line, 0, and those two numbers, they are dividing the entire real line to how many interval? How many sub interval you have? 3. From minus infinity to 0, from 0 to 1.5, and from here from 1.5 to plus infinity. So I have 3 sub interval from minus infinity to 0, and from 0 to 1.5, and from 1.5 to plus infinity. Those two number dividing the entire real line, 3 sub interval. Then I have to check. Our goal here is to solve this inequality star here, this one. So I have to replace x by, I have to replace x, I have to check which interval is a solution. Which interval is a solution. So here, for simplicity, 0 to minus infinity, take any number you wish. Take x equal negative 1, for example. X equal negative 1. Then I go back here. Then I replace x by negative 1, right? X replace x by negative 1. If I replace x by negative 1, what did you get? Let me show you. You are going to get 4 negative 1 cube minus, right? Just replace x here. That is your x by negative 1. Then you have negative 6 and negative 1 squared. If I simplify that, you get negative 4. And here, what do you have? You have negative 6. So what did you get? You get negative 10. So if you have negative 10, and this inequality must be greater than or equal 0. So when I take x equal negative 1, then your inequality is there negative. So which means this one is not a solution. That is not a solution because it's negative. So I go for the second one between 0 and 1.5. For example, take x equal 1. Take x equal 1. So I go back to star. I replace x by 1. Then you have 4 minus 6. Again, 4 minus 6 here. It's negative. So that is not a solution. So I cross that. So here I have my inequality negative. And here I have negative. So what is the last one? 1.5. For simplicity, take x equal 2. Any number you wish from here. If I take x equal 2, just go ahead and replace x by 2. So what you have? You have 4. You have 4 multiplied by 2 to the power 3 minus 6 2 to the power square. If I simplify that, you get 32 minus 24. So what did you get? You get 8, which is positive. So that is this one here, it's positive. So I put check on that. So which means my inequality is greater than 0, positive, means your derivative is positive, and then the function here is increasing. So where is the interval where f is increasing? So f here is increasing. I'm just writing this. F is increasing over the interval 1.5 to plus infinity. 1.5 to plus infinity, that is where my inequality is positive. And the other two, your inequality is negative, your derivative is negative. Look what you have. That is, my derivative is negative. Then what can you guess? That is where f is decreasing. F is decreasing. F is decreasing. Where is f is decreasing? F is decreasing from here. I have over this subinterval, which is minus infinity to 0, or here, or and just write 0 to 1.5. All right. So that is where f is decreasing, because your inequality is negative. Means what is your inequality? That is your derivative is negative. When your derivative is negative, look what you have. I wrote the rule there. When my derivative is negative, means f is decreasing. When the derivative is positive, then f is increasing. But that is very good, because you need to find the interval where f is increasing and where f is decreasing. When f is increasing and when f is decreasing. Okay. So I have here another example here. Maybe I have to figure out what is the interval here I have. Let me give you another example here, which is you have your f of x equal to your f of x cubed minus 2x squared minus 4x plus 1. All right, so x cubed minus 2x squared minus 4x plus 1. So I need to figure out the interval where f is increasing and where f is decreasing. So step number 1, I have to take the derivative, because the derivative here is 3x squared minus 4x minus 4, right? So that is our derivative. So now I need to figure out where is f is increasing, where is f is decreasing, where is f is increasing, and where is f is decreasing. What is the interval? So now, so f is increasing means your derivative here, your derivative should be greater than or equal 0, which is 3x squared minus 4x minus 4 should be greater than or equal 0. So how to solve this one here? That is called quadratic, because the highest power is 2, quadratic inequality. I need to solve this by 2 steps. Step number 1, you make it equal to 0. You make this one equal to 0. 3x squared minus 4x minus 4 equals 0. Then how to solve this one? You could solve it by quadratic formula. Use quadratic formula here, right? So to get 2 number, minus 4ac over 2a. So that is your 2 number here, which is negative b plus or minus b squared minus 4ac, right? So that is quadratic formula. So I can factor this one here. Let me give you the numbers. So you have 3x, right? And here plus 2, and here x minus 2, and that is, right? So equate that to 0. So 3x, if I factor this, I got this one here, right? But you can use quadratic formula, you get the same number. So here I have x equal 2, that is 1, that's come from here. The second one, 3x plus 2 equals 0. So your 3x equal negative 2. So what is your x? Negative 2/3. Negative 2/3, right? So now I have 2 numbers. You can use quadratic formula. You get to give you the same numbers. So now that's step number 1. I make this inequality equal to 0. Step number 2 here, I have to put that on the entire real line here. Where is negative 2/3? It's here. Where is 2? I put it here. So those 2 numbers, they are dividing the whole entire real line to 3 subintervals. From 1 minus infinity to negative 2/3. Negative 2/3, and from negative 2/3 to 2, and from 2 to plus infinity. So I have 3 subinterval, 2 number dividing the entire real line to 3 subinterval, minus infinity to negative 2/3, and from negative 2/3 to 2, and from 2 to plus infinity, right? So now, all right, so now I have to check which one satisfying this inequality. Where is f is increasing here, greater than or equal 0, all right? So I have to try between negative 2/3 and 2. which number is easy to pick? X equals 0, right? X equals 0, that's the easy number. So if I go to star, because that is the one I need to figure out, that is our derivative. I replace x by 0, guys. If I replace x by 0, what do you have? If I replace x by 0, you get 0, 0. So what you have here? Negative 4. Is negative 4 greater than or equal 0? No. So I get negative 4 is not equal to greater than 0. So this one is not increasing, but indeed it's decreasing. Why is decreasing? Because your derivative here, this inequality, that's our derivative, is negative. So now I have to check here, take x equals, say, 3, right? So I have to go back to here. I put it x equals 3. So you have 3, right? So just 3, here 3 square minus, right? Just minus 4 multiplied by 3, right? And you have minus 4, right? So if I simplify this, so you have here, that is 27 multiplied by 3, right? So 3 multiplied, so you have to use technology for this. It's very clear this one is positive. It's very clear it's positive. So this one here, that is where the function here is increasing. Your function here is increasing because your derivative is positive. Your derivative, that is your inequality, derivative positive, then the function is increasing. If your derivative plus 1, take x between minus infinity to negative. So if we take, say, negative 2, for example, negative 2 is negative 2 here, yes, or negative 1. If I put it here, just replace x by negative 2. So what do you have? You have 3 negative 2 square, right, minus 4 multiplied by negative 2 minus 4, right, minus 4. So if I simplify this, 3 multiplied by 4, you get 12, and here you get negative times negative, you get 8, and here minus 4. So what did you get? 20 minus 4, you get plus 16. So turn out this one here is increasing. This one, it turned out, also is increasing, right? So now where is the function is decreasing, and where is the function? So f is decreasing, going down, decreasing when your derivative is negative. When the derivative is negative, where is your derivative is negative? Over this interval, right? Negative 2/3 and 2. Where is f? Here is increasing. F is increasing when you have the first one minus infinity to negative 2/3, and here you can write and 2 plus infinity, 2 plus infinity. All right. So that is the conclusion here. Is when I give you function to figure out the interval f is increasing, where is f is increasing, where is f decreasing? Step number 1, go ahead and take the derivative. After you take the derivative, then if the derivative greater than or equal 0, then f is increasing. When the derivative less than or equal 0, then f is decreasing. So I took the derivative, and then I assume f is increasing, which means greater than or equal 0. Then it turned out you have inequality. How to solve this inequality? Then two-step solving. That is the general way to solve any inequality. 2 steps. Step number 1, you make it equal to 0. Then use quadratic formula or just solve it. After you solve it, you get 2 numbers. You put that on the entire real line. Those 2 numbers dividing the whole real line to 3 sub-interval. You have to check which interval is make my inequality or make my derivative positive. That is the one where f is increasing. Which interval make my derivative is negative? That is where f is decreasing. Okay, guys? So now, so that is kind of one application for the derivative by taking the first derivative. Here we take the first derivative to figure out where is f is increasing, where is f is decreasing. All right. So now I'm going to apply this one here to next time to find the minimum and the maximum. All right, guys. So I will stop here and we continue next time. All right. Thank you.